In this video, you will continue working on your lecture work packet on number 12. We will continue looking at how to find the scientific notation for small numbers. The same rule still applies. You will find a number between 1 and 10 and multiply it by a power of 10. Alright, let's look at an example. The largest approximate width of a coronavirus strain is 14 millionths of a meter, or 14 micrometers. We can write this in scientific notation form as follows. Remember, we want to write our first part of our number as a number between 1 and 10. That means we want the decimal point to be between the 1 and the 4. Then we will multiply it by a base 10. To find the base 10, remember we want to see how many times we will move the decimal point to get to its current location. Before we do that, let's take a look again at the summary of the base 10 system. Remember, when we deal with smaller numbers, we are dealing with the tenths, the hundredths, and thousands, etc. Remember, with the base 10, we are dealing with the negative numbers, which lets us know that we're going smaller each time that number rises. If you recall, the number that's in the exponent of the base 10 directly corresponds with the first non-zero digit in the number. If we look at 10 to the power of negative 7, or 10 millions, what we'll notice is that we can count the amount of place values that it takes to move the decimal point behind the 1. Because we want our decimal number to be a number between 1 and 10, we count the movement of the decimal point until we can get that number to be between 1 and 10. 1, 2, 3, 4, 5, 6, 7. Notice we are counting the place values of moving the decimal point and not the zeros. Each time we go to the right or go smaller, we are dividing by 10. Once we get to the ones place or the units place, we can clearly see how this system will work. Alright, remember our question has said the largest possible width of a coronavirus strain is approximately 14 microns, or 14 millionths of a meter. Because we know the decimal point has to be between the 1 and 4, we now just need to count how many times we move it to the right to see what our negative power would be in the base 10. 1, 2, 3, 4, 5, 6. That means our base 10 would be 10 to the power of negative 6. So our answer is 1 and 4 tenths times 10 to the power of negative 6. Let's see if you can do these on your own. Go ahead and pause the video, write the answers in your lecture work packet, and then replay the video to see if you got it correct. Or you can just work with me as I go through the problems. Okay, so how would we write this first number in scientific notation? Well, we first want to see where the decimal point would go. In order to be between 1 and 10, the decimal point would have to be behind the 6. 1, 2, 3, 4. Because we move 4 to the right, that means our base will be 10 to the negative power of 4. So our answer is simply 6 times 10 to the power of negative 4. For the second number, we need our decimal point to be in between the 7 and the 2. So we count how many times we move it. 1, 2, 3, 4, 5, 6, 7. So that's 7 and 2 tenths times 10 to the power of negative 7. Where should the decimal point be for the third number? If you said between the 5 and the 0 that follows it to the right, then you would be correct. Let's go ahead and count to see what our base 10 would be. 1, 2, 3, 4, 5. So our answer is 5 and 2 hundredths times 10 to the power of negative 5. Where should the decimal point go for this next number? If you said between the 3 and the 2, then you would be correct. 1, 2, 3, 4, 5, 6, 7, 8. That means our base 10 would be 10 to the power of negative 8. And our final answer, 3 and 29 hundredths times 10 to the power of negative 8. Okay, let's do the last one. Where would the decimal point go for this one? The decimal point would have to go after the 1 and before the next 0. Now we can see what the negative power would be in our base 10. 1, 2, 3. So that means our answer is 1 and 8 thousandths times 10 to the power of negative 3. That's how we write small numbers into scientific notation. Go ahead and finish the quiz and the assignments for this section.